Hi, I'm Jianhao Jiao, the Research Associate from the Hong Kong University of Science and Technology. And in this talk, I will introduce my 6-month research plan for the RoboHack project. And from my understandings regarding the working package 1 and 2, this will involve several open problems, like how to choose proper sensor combination, and the second problem should be how to reconstruct the local terrain precisely using onboard sensors and PCs for downstream navigation tasks. And this is a very important problem. And third problem should be how to determine traversable regions in off-road scenarios, and so on. And solving this problem will induce several challenges, like changing environments, including long-term change or short-term change, or localization drift in large-scale or long-term navigation, limited computational resource, terrain variation, and so on. The first 6 months, I will focus on the reconstruction problems of local terrain. And the key motivation is very straightforward. Since the local terrain reconstruction map is very important for downstream navigation, but jerky motion of leak robots reduce the quality of sensor data, like motion birds in cameras and automatic results provided by SLAM. And these issues will affect the quality of local terrain reconstruction. And about the map representation, I will choose the elevation map. Since elevation map is very efficient on board device, and since it represents as an image, so this data type, data format is very friendly to GPU or deep learning network. But if you want to directly register the elevation map with RGB or LiDAR scan, the problem is unsolved and very challenging since they use different data modalities. So in this plan, I will contribute two things. The first thing is I will propose a new registration method to register the elevation map with LiDAR scan. And this method should be robust to large automatic drift and fast. And this algorithm will be deployed on a real robot. The first category of work should be the non-perceptive locomotion control approach. And this work is very robust to automatic drift, but the current use 2D occupancy map, this map representation has very limited expressiveness, and it represents some complex terrain. So I will prefer the perceptive locomotion approach. And this paper proposes a learning-based elevation mapping reconstruction methods for urban light environment, and the neural network should be robust to partial occlusion and small automatic drift. But to be honest, these methods cannot address large automatic drift and cannot be generalized to irregular objects, since these objects cannot be modeled in simulators. And this is a similar work in terrain reconstruction, but focusing on 3D Warsaw map generation has similar issues, but more importantly, these methods based on 4D convolution require high computation burdens and memory footprints. So in this plan, I will focus on the elevation mapping methods, and I will propose a new registration method to online estimate the pose to improve the quality of elevation map. For the SLAM part, I will use the state-of-the-art LiDAR SLAM inertial automatic light fast LIO with this small mid LiDAR. And in registration, I will propose a new data association methods like converting the elevation map and scan into a uniform data format, and propose an outlier rejection method to improve the ratio of inliers, and propose pose estimation methods to using the local methods or global methods to estimate the pose accurately. And I will evaluate this method and compare with two baseline methods, including the traditional elevation mapping methods and learning-based methods, as mentioned before. And in experiments, I will deploy the algorithm on a Jane dock or other robot dock, and with the Jetson Orange computation platform, and test the algorithm in scenarios like urban light environments, including the stairs, corridors, and off-road environments like grassland and trees, as shown in this picture. Oh, that's all. Okay, that's all on my plans. But beyond the 6 months, my future work could include three things, three directions. First, I will record the perception using the molecular or VIO-based perception methods to reconstruct the local terrain without relying on LiDAR or RGB sensors. And the second could be record the semantic mapping of terrain using the semantic map to determine traversable regions and help the robot to navigate. The third direction should be to state at the intersection between mapping and navigation. It should be include the high-level scene understanding and consider how to address an environment into a sparse graph and use this sparse graph to help robots for high-level navigation and exploration. Okay, that's all my plans. If you have any question, please tell me. Thanks.